Hi, welcome to Science 1206, the motion unit. I'm Miss Ledwell, and in this video, we'll talk about distance and displacement. Let's get started. Distance, with the symbol lowercase d, refers to the total length of the path an object moves on. It doesn't matter which direction the object moves in. What's important is how far it travels. For example, if a horse runs 500 meters in a straight line, the distance is 500 meters. If another horse runs around a circular track and covers 500 meters, the distance is still 500 meters. The shape of the path, straight line or circular, and the direction of movement do not affect the distance measurement. The SI unit for measuring distance is meters, with the symbol lowercase m. Let's explore the concept of distance using Buddy the dog as our guide. First, we'll look at the starting point. Buddy starts at position 0, all set for his daily exercise. His first move is he runs to the right, ending up at a position of +4. The distance he traveled so far is a distance of 4 units. Buddy's next move is to run back to the left, stopping at position +2. What was Buddy's total distance traveled? Well, Buddy first covered 4 units to the right, then another 2 units to the left. This means Buddy has covered a total distance of 6 units. 4 units plus 2 units gives us 6 units during his exercise. Remember, the total distance traveled by Buddy is the sum of all his movements without considering the direction. Next, let's look at displacement. Displacement, with the symbol delta D with an arrow over it, is the difference between an object's initial position and its final position, regardless of the path taken. In other words, displacement is the change in the object's position from some starting point. The symbol of a little triangle is the Greek letter delta, meaning change in, and the SI unit for displacement is meters, with a symbol of lowercase m. Let's look at an example of displacement. A hiker leaves their campsite, walks 2 kilometers north, then 1 kilometer south, and stops for a break. Their displacement is only 1 kilometer north of the campsite. 1 kilometer north is the difference between their initial position and final position. Let's look at another example of displacement. We'll revisit the example with Buddy the dog to determine his displacement. Buddy starts at position 0, ready for a little adventure. His first move is to run 4 units to the right. So far, his displacement is 4 units right. Buddy's next move is to run back 2 units to the left. Your total displacement is all about where you end up relative to where you started. Buddy has moved 4 units to the right and 2 units back to the left. So the total displacement, or change in his position from his starting point, is 2 units right. Remember, when we did the same example with distance, the distance moved was 6 units because we didn't consider direction when we talked about distance. Let's look at some examples and determine whether the description is of distance or displacement. Here's our first one. 709 meters. Distance or displacement? This one is distance because there's no direction given. 8,545 kilometers east. This is an example of displacement because we have the numerical value followed by the direction. 2.2 centimeters is a distance. There's no direction indicated. 15 meters south is displacement. We have the numerical value and the direction. 13 kilometers north is also displacement. We have the numerical value and also the direction indicated. Now it's time to continue to the next video. Before you do, take a 30-second break Stand up and stretch and then continue on.